Hello everyone. In this video, we are just going to understand how embedded firmwares are developed in real-world applications. Let's get started. And the first and foremost systems that we are going to discuss is the busy wait systems. Let's take an example for understanding this particular busy wait systems. The example that I'm going to take is the anti-lock braking system or ABS systems that is available in modern cars, lorries, bikes, etc. And here you can see we have three different sensors. First one is the pedal travel sensor, next one is the brake fluid sensor, and third one is the pressure sensor. And then we will process the data based on these three inputs. Just consider these three inputs for now. Over this, we have a lot of sensors in this ABS system. We are not going to see that in detail. Instead, we are just going to take this as an example for understanding the system that we are discussing right over here. That is the busy wait system. So here in the first step, we are just going to check whether the pedal is pressed, and we are just going to read that particular data in our system. And sequentially, after reading the pedal travel sensor data, we are just going to come to the brake fluid sensor data, which tells us whether the amount of brake fluid is enough for applying the brake. And further, after updating the brake fluid sensor data, we are just going to check for the pressure data in the cylinder, which will check and provide us the detail that the amount of pressure available in the cylinder is enough for braking the system. And then further we will go to the next process in braking system. In this particular sequential system, which is also called as busy wait system, we can clearly understand this particular system is capable for a simple applications where safety criticality is much lower. But in this example of anti-lock braking system or ABS, there is a risk involved in human lives. If something is going wrong, there will be an accident occurring at the road. So this is the most safety critical system. So for these kinds of systems, the busy wait system is not suitable. For instance, let's take, we got the pedal travel sensor data and we got the brake fluid sensor data. While executing and checking for the pressure sensor data, we got a new update in the brake fluid sensor stating that the brake fluid sensor is not sufficient. But the processor will be processing the data at this point in the pressure sensor reading region, so that it will neglect the updation happened right over here in the previous step. And further it will go to the next step, which will spoil the whole system for an accident. So this is how this particular busy wait system is not capable for safety critical applications. We want a certain system which will be suitable for running each thread in a parallel sequence. That we will see in the next video. I hope you understood what is busy wait system in this particular video. See you in the next video. Thanks for watching.